And a big hello to everybody down there on the Bass Coast and South Gippsland. It's Graeme Anderson here from Agriculture Victoria with a bit of a climate update. And a big shout out to Joel and all of the team there on the project, the climate adaptation project, Growing South Gippsland, doing a great job. Well done to all of the partners collaborating in that. There's some really good resources and video material and tools. Just head to the Growing Southern Gippsland website. So our team at Agriculture Victoria puts out quite a few climate tools. So the Break newsletter provides a monthly commentary on seasonal forecasts. It's free. There's also soil moisture probe updates, which we've got under paddocks, measuring how much moisture is in the top metre of the soil. There's quite a lot of forums we do, also climate webinars that people can tap into from home to watch live or to watch the recordings. A lot of products we've got, and also all available at that website, agriculture/climate risk. I'm going to just start by talking about rainfall last year. This is 2019, Australia's rainfall, and this is compared to long-term average. So basically deciles. Decile 1 is in the driest 10% of years. Decile 10 is where it was in the wettest 10% of years. But just take a note of how much of Australia had this darkest red, which was the driest year on record for those areas. So it's extraordinary, and the climatologists are amazed that so much of the country can have just shared its driest year on record. Note down here in South Gippsland, we were one of the few areas that was pretty close to average, so all good, saved by all of the cold frontal activity that whizzed through here last year, so that was terrific. But note here also this area up here around Julia Creek, all of that rain tended to happen mostly in about 7 to 10 days. So that was an extreme rainfall event in the first week in February 2019, which I guess there's a broader story here in terms of while we've got natural variability, there is an increasing chance for warmer and drier, which is coming with climate change, but also increases of extremes, which is sort of what happened here. So part of it is how we set up our systems to better deal with that sort of variability when it happens in our patch. Now I've got a long-term rainfall record here. This is going back to 1916s. It's for Ventnor and Phillip Island. So this is 1916 here. This line through the middle is the long-term average, which is 775 mils. You can see the 800 mil mark there. And this is just that variability through that time. If you look at the last 20 years, you can see that we've had 13 drier and 7 wetter, but a lot of variability there. This is Ventnor's, but just looking at the summer, autumn, winter and spring rainfall. Again, you can see plenty of variability in all of those seasons, and we'll talk about why. Probably the one season that's a bit different is autumns. If you look at the last sort of 30 years, autumn's been commonly a little bit more drier. It's been the one season a bit drier. Have another location here, Wonthaggi rainfall record back to 1912. Long-term record here, average is 936, so a bit wetter. And you can see there plenty of variability throughout the years. In the last 20 years there, when we look at Wonthaggi, it's interesting, 10 have been drier, 10 have been wetter, so pretty well no different to long-term average. So it's interesting, just depending on where you travel around, most regions there's a bit of variation. Some have had a much drier time of it in the last 20 years, and others have had pretty well close to average. So it just shows that it does vary depending on sometimes even which parts of the range you're in. Here's Wonthaggi, summer, autumn, winter, spring rainfall. Again, a lot of variability in the mix there. Probably, certainly in the last few years, been not as many wetter summers, but again, there's a few more common to have drier autumns there. Now there's a longer term record here from Inverloch, goes back to 1885, and it's a pretty good one. You can sort of see there, the sort of part of the Federation drought and World War I droughts. Some wetter years post the 50s, pretty typical. And again, if you look at that last 20 years, not too bad, 12 drier, 8 wetter. You can see the Millennium Drought in amongst it. So plenty of variability. When we look at the summer, autumn, winter and spring, again, plenty of variability in the system there, and there's that sort of bit of a signature of a few more dry autumns thrown in. So to talk about what drives their variability, I guess what we'll start with is, the wettest part of the planet is along the equator and the tropics, and this is basically measuring the amount of precipitable water that's in the atmosphere. And in years where we have wetter years, usually down in this part of the world, it's to do with when there's a lot more moisture circulating around these parts, and that varies from year to year. So a lot of the forecasters sort of look at that, and we'll talk about what drives that. And here's the key drivers to our wetter and drier years. So you can sort of see here's Antarctica, and here we are in southeastern Australia, and you can sort of see the southern annular mode. There's all of these really strong winds that whiz around the Southern Ocean, and they are the conveyor belt for all of these cold fronts that whiz across and provide those regular triggers, which is why we have pretty reliable rainfall in South Gippsland. And wetter years are when you can see the Pacific here, the El Nino Southern Oscillation. Some years there's a lot more moisture and cloud that's feeding in here, and when that feeds in and hits these regular frontal triggers, then they're wetter years. You can see the Indian Ocean dipole. Some years when it's feeding in heaps of moisture, again, it's a really important driver behind both wetter and dry years. You can notice here, though, the really important bits about the southern annular mode. It's really a driver of this sort of the rainfall triggers, but also we have what's called the subtropical ridge, and it sits here, and it's where the high pressure patterns come along and sit, and so there's a bit of a battle between these two. But I know a lot of farmers have certainly noticed that, in the sort of 60s, 70s and 80s, if you saw a cold front off the coast of Perth, you'd expect rain, in Victoria 3 days later. And what we've noticed a lot, certainly since the mid 90s, is if you see a cold front over here, we watch them slide a bit further south, and largely that's sort of part of what we're expecting to see more often, which is just the pressure pattern getting a bit stronger and some of these fronts starting to shift south. So that's sort of part of that story of wider variability, but also the early signs of climate change. And just as an example, here's some sea surface temperature maps that goes back to a dry pattern. Along the equator, the ocean's a lot warmer, but this is just showing up areas of ocean that's warmer than normal or cooler than normal, which is the bluer colour. So this is a typical drier pattern for Southeast Australia, where there's an El Nino in the Pacific, extra warmth out here, all the extra clouds being dragged out into that way, so there'll be sort of floods in Peru. And this cooler water to our north would mean that there's actually less clouds in this area over New Guinea and less moisture feeding into our weather pattern. So that's a typical sort of dry sort of weather pattern that you might have, and that's back in the drought in 2006. Keep an eye on this particular area as we look at, say, a wet pattern, and we'll go to a similar period in 2010. So 2010, you can see big La Nina in the Pacific. All the warmest water was in our part of the world then, heaps of cloud and heaps of moisture feeding into those weather events. So that's sort of the biggest systems that are behind some of those wetter and dry years. And we've got a tool here. There's a new website, Forecast for Profit, which you can have a look at, but it's got Leongatha's rainfall there from since 1900. It goes through and plots the long-term average. But it's just interesting here, we've got these colours here are basically years when a particular tropical climate driver was active in a wetter or dry phase. So, and it's interesting just to have a look at that, because you can look at some of these bigger drier years. These were years when there was an El Nino, so a drier phase in the Pacific combined with a positive ID, which is a drier phase of the Indian Ocean. So when both of them have teamed up, it's certainly got its fingerprints over our dry years. So a lot of that is what's behind the core drivers of our climate variability. So the question is there anything happening at the minute that's different to just long-term variability? And one key difference that we have is actually around maximum temperatures. Here's maps of maximum temperature from Australia from 1910 through each decade. You can sort of see the blue colours are cooler than average years, the yellow and orange is warmer than average years. And you can just notice while there's a lot of variability there, there's certainly been an increasing trend, especially in the last sort of 20 years, towards increasing temperatures. So while we've got increasing temperatures happening, we might still have increasing variability in rainfall. Largely the climate change signal is around this increasing temperatures. And as you can see here, here's some maximum temperatures for southeastern Australia, and it's just from 1910 through to 2019. This is for summer, autumn, winter and spring. So you can see in all of those seasons there's a warming trend. There's a lot of variability from year to year. And if you look at spring's probably our fastest warming season. In the last sort of 15 years, spring's been between 1, 2 and almost 3 degrees warmer than the long-term average. So that's sort of like a month earlier, basically, when you're looking at that. So the simple way of looking at this temperature change is that it's basically like squeezing in an extra month of summer, and an extra 1 month now, but in future we'll be sort of adding to that. So this is part of that increasing temperature signal. And so while we've had those increasing temperatures in recent decades, it's also a trend that's expected to continue. And here's sort of projections here from the Victoria Climate Science Report. But you can see here, this is temperatures across Australia. Average, the jagged line is what's been observed, and you can see them sort of increasing in recent decades. But also what you've got here is some of the modelling projections. Now, this particular band here is when the climate scientists model our climate variability, and if they don't include the increase in greenhouse gases, then this is what would have happened with just natural variability alone. But we've known a lot about greenhouse gases, and even right back since the 1850s they've been proven to trap heat, and as we add more greenhouse gases in the atmosphere, they trap more heat, and when you include that in the climate change models, this is the sort of range of projections you get, and you can see that if anything isn't quite keeping up, I think some of those temperature trends are happening a little bit ahead of schedule, but that's what's been expected, that's what's happened, and you can see future climate projections just show that the more greenhouse gases we add in the atmosphere, the more heat that gets trapped and the greater the amount of warming. So we're going to see a lot more effort in the next couple of decades, not just here but globally, around how we're trying to limit those sort of maximum temperatures in future and try and limit that damage by reducing emissions. And there's a lot of opportunities in that shift in terms of how in agriculture but also across society we can find ways of doing all the good things we want to do, but with minimum emissions. That recent study on the analysis of Victoria's changing climate, this was a bit of a summary of the key things. Largely the storm tracks, certainly for southern Australia, which is part of our reliable rainfall. Some of that's just shifting south. The pressure pattern above our heads is a bit stronger than it's been in the past, and that's all expected with it's being measured, and it's also what they expect in the climate models. Probably a few things are happening a bit quicker than what they might have anticipated, but you can go to get more details in that report. There's also regional brochures on the new climate change projections, which you can get at that website. And this is also a good little publication. The Bureau of Meteorology have put out some 4-page local fact sheets on recent climate. So this is one for West Gippsland. You can get it at that website. It just goes through the last 30 years and how that compares to the longer term history. So for Gippsland, rainfall's been pretty stable. It's probably decreased a bit in autumn. Talks about there is some incidence of increased spring frosts, but also been an increase in the number of hot days. But some good little fact sheet and worth checking out. So I would just like to, in terms of a quick summary of the climate projections, there's high confidence in some elements such as increasing heat, and when you warm up the planet, the tropics expands either side of the equator and nudges everything towards the poles. So from our point of view in southern Australia, the drier patterns largely because of those all that cold frontal activity gets just shifted a bit further south. Also increasing confidence of when conditions are lining up to be wet, we can have more rainfall out in a shorter time period. So the model runs can vary. There's still, I guess what we're sort of trying to plan for in agriculture is for more variability, a bigger summer, so warmer temperatures on average, more likely to see drier conditions, but it can still be very wet, especially when those ocean patterns line up. There's also uncertainty, so certainly a lot of 90% of the heat that's being trapped at the minute is going into our ocean. So how that plays out in the El Nino Southern Oscillation cycle and the Indian Ocean and Indian Ocean Dipole cycle and these things is going to be really critical. So there's potential for surprises where some of these particular issues might play out a bit differently to what's expected in the climate change projections. But if they do, they'll just add to more variability. So we've still got to, we'll have to deal with that as we go. We've also got issues to deal with just in terms of potential curveballs, such as one thing with those warmer days in spring that can make things want to flower a bit earlier, but we're actually noticing because of that sort of higher pressure pattern, we're still getting some quite a bit of frost risk and some late frost. So if you imagine that's not a good combination, warmer days, plant wants to flower a bit earlier, but if frost risk is still hanging around, or in some areas if it's the risk of late frost is still quite strong, that can actually be quite a tricky combination. Also, slow-moving weather events. There's a few uncertainties there in terms of how this plays out with weather patterns, but all we've got in control is the planning for dealing with that variability. Also, the other bit gets talked about with climate change is the 3 Ps. And the 3 Ps of climate change is the physical effect. So I've talked a lot about that, which is really what the weather does and how we've got to prepare for those impacts of a farm that can handle that variability. But there's a really key change that will affect a lot of businesses, and there's lots of opportunities in this space too, which is around dealing with some of the impacts of the changes to policies around areas such as water conservation, water security, energy, carbon trading, renewables, bushfire response, planning, drought support. Lots of those things are areas, and there's lots of opportunities there as there's the shift towards some of that lower emissions work, and also, products and practices which improve our adaptability. Also, really important, the other P is just about how others are changing, and so there's some major changes happening at the moment with how banks are responding, insurance, because the insurance companies are the ultimate bookmakers for risks of weather. There's a lot of work going on to understand what's changing and how they manage those risks. There's also changes by consumers along trade and market supply chains, and in terms of food and fibre production, all of that is sort of part of what we've got to deal with in terms of, dealing with the implications of climate change. So there's certainly risks amongst that, but there's lots of opportunity for Australian agriculture here too. So the weather's a tricky topic sometimes, and often a bit frustrating because we're not in full control of what's going on there. So one of the key things is steps to taking actions on your own properties, and what can you do that's under your control. And I guess here's a bunch of things which we're seeing that are being applied across agriculture, which really help set people up for the future. And, we've got a good stream of modern technologies and research and development that you can tap into. Always, we've got improved genetics and lots of innovations, which we're seeing lots of farmers doing things better than we have before. So that's all continuing, and we'll need more of it. Also, a really important role for improved farm and regional infrastructure. So whether it's to do with storage of water or fodder, but also other things like communications and transport and basically the things that help sets up regions where we want to live, places where we want to live and work. And so we've got a lot of that under our control, and part of that is just dealing with more variability. There's lots of opportunities with growth in local and export markets, but also needs to be underpinned by really good biosecurity management. So that's going to be really important. We've certainly seen that volatility from year to year, not just with seasons, but also with the business cycle, is increasingly important. So managing that volatility in business is really becoming a more and more important part of farming. And also there's been great work done by Landcare in particular around just improving farm planning, how we manage our soils and maintain pasture cover and the natural resource management skills. All of that stuff is just absolutely what's needed for making a more robust landscape to deal with greater extremes of weather. And one of the really key things is making sure you're part of good knowledge networks and good networks of people, knowledge channels, surrounding yourself with people who can help you solve different issues, and we'll learn and develop all of this together, and gives us confidence to grow and invest in the things that make our farms better off and our livelihoods better off. So there's lots of upsides in how we'll tackle this. And so thanks for tuning in, and congrats to everyone in the Growing Southern Gippsland project. Some really good resources there, and we've got some other information if you want from Agriculture Victoria. If you want to get the Break newsletter or see any of those tools, just head to that website. So all the best.